Hello my dear friends, welcome back to the another very interesting video lecture from your YouTube channel ADC Max. Modulation property, how it is modulated. So I'm going to introduce the modulation property for complex Fourier transform and also Fourier sine and cosine transform in this video. Okay, let us go for it. First, what is the modulation property? Says that if the Fourier transform of f of x is equal to f of s, then the product of f of x along with the trigonometric function, because already we have seen that the product of exponential function e to the power f of x into e to the power iax is called f of s plus a, and the Fourier transform to the minus iax into f of x is equal to f of s minus a. So this is the another separate property. I made a separate video in detail about these types of properties. Please go and watch. Okay. Now my question is, what is the answer when it is a product of the trigonometric function along with f of x? So I want to use the same concept. Before going to that, if you remember, what is the cos theta is equal to is e to the power I theta plus e to the power minus I theta by 2. If you know this results, that is very easy for getting the modulation property. So now the proof, the left hand side, the Fourier transform of f of x is equal to cos ax. I can rewrite the cos ax with the help of the result cos theta is equal to Fourier transform of f of x into e to the power I. In the place of theta is here ax, is right? So e to the power iax plus e to the power minus iax by 2. So by using the cos theta equal to e power I theta plus e power minus I theta by 2. So by using the linear property, the constant term 1 by 2 coming outside, and let's rewrite this by using the linear property. When I multiply f of x into the term, so e to the power ax into f of x plus Fourier transform of f of x into e to the power minus ax. So this is exactly looks like these two properties. So it's equal to 1 by 2 into f of x to the power iax. So plus ia means it is f of s plus a, and it is minus means f of s minus a. So this is the modulation property. So hence the modulation property for the complex Fourier transform. So the same case, so product of f of x into the trigonometric function cos ax, then we get the answer. But actually the trigonometric function is sine is also there. So what is f of x into sine ax? What is f of x into cos ax under the Fourier sine transform and Fourier cosine transform? That is the other set of modulation properties under the Fourier sine and cosine transforms. So let us see that. My question is here. This is the modulation property for the complex Fourier transform is over now. Now my question is, what are the modulation properties of Fourier sine transform of f of x into sine ax? What is the Fourier cosine transform of f of x into sine ax? Similarly, what is the Fourier sine transform of f of x into cos ax? What is the Fourier cosine transform of f of x into cos ax? So these four properties are known as the modulation property under the Fourier sine and cosine transforms. Got it? Let us go one by one. Each results which completely depends upon some trigonometric identities. So let's go for one by one now. So I would like to start with the first one. What's first one? Fourier sine transform of f of x into sine ax. Fourier sine transform of f of x into sine ax. Right? So this is equal to square root of 2 by pi integral 0 to infinity f of x into sine ax. So this is the given input, right? And sine transform. So sine sx into dx. Is right? The sine transform is there, so it is sine sx. So this can be the square root of 2 by pi integral 0 to infinity f of x into sin ax sin sx. This looks like sin a sin b formula. What is sin a sin b? Otherwise 2 sin a sin b is equal to cos a minus b minus cos a plus b. So once if you know this trigonometric identity, it is very simple. I have considered a equal to sx, b equal to ax. So what happened when I apply this result? Sin a cos b. So sin a sin b. Sin a sin b is equal to 2 times. So it's here 1 by 2. So 1 by 2 times cos of a minus b. So a minus b. Sx minus ax. S minus a into x. So what about a plus b means? A plus b means s plus a into x. A minus b means s minus a into x. Right? It's clear? Now, cos of a minus b minus cos of a plus b. So, s plus a into x into dx. Is right? Is it clear? Very simple concept. Now, this 1 by 2 taken outside. So, 1 by 2 into, by using the linear property, this can be split up into two separate integrals. 0 to infinity f of x cos of s minus a into x dx. Right? 1 by 2 is common. And this minus sign, root 2 by pi, integral 0 to infinity f of x into cos of s plus a into x dx. Now this is under the cosine transform, output is s minus e. This is also under the cosine transform in terms of s plus e. Minus sign behind the term. So this is the over, this is 1 by 2. So this is the answer for the modulation property for a sine transform of f of x into sin ax is equal to 1 by 2 for a cosine transform of s minus a minus fc of s plus a. So only 1, 2, 3. 3 steps only, but you should know this result will give the answer. In the same manner, we are going to find out the others also. For a sine transform of f of x into cos ax. You have to get the Fourier sine transform of f of x into cos ax. Let us see how to get the Fourier cosine transform. So how to get the cosine transform of f of x into cos ax. So Fourier sine transform of f of x into cos ax. So what's the answer? Once again, by the definition is root 2 by pi integral 0 to infinity f of x into cos ax. So this is the given input under the cosine transform. So it is sin sx into dx. So this is the a, this is the b. But this looks like sin a cos b formula. So if you know sin a cos b, well and good. What is the 2 sin a cos b? Yeah, what is 2 sin a cos b? Sin a plus b plus sin a minus b, isn't it? Here a equal to sx and b equal to ax. So a plus b is equal to sx plus ax, otherwise s plus a into x, and a minus b is equal to sx minus ax, otherwise s minus a into x. The same concept only. So by using the result, I am getting that square root of 2 by pi integral 0 to infinity f of x. So as it is written f of x here. By combining these two terms, by using this result, 1 by 2 is coming down, and sine of a plus b. So sine of sx plus ax is plus ax plus sine of a minus b. So sine of s minus a into x. That's it. Into dx. Now let us use the linear property. 1 by 2 is taken outside. So root 2 by pi integral 0 to infinity f of x sine of s plus a into x dx plus this plus square root of 2 by pi integral 0 to infinity f of x multiplied to the term. So f of x sine of s minus a into x dx. I think this looks like the Fourier sine transform of s plus a, is right? Plus sine Fourier sine transform of s minus a. In front of that I have 1 by 2, so this is 1 by 2. So this is the modulation property for the Fourier sine transform of f of x into cos ax. In the similar way, we get the Fourier cosine transform of f of x into cos ax. So cosine transform is, this is cos ax. So this becomes cos ax. So this becomes cos a cos b. What's the cos a cos b formula? You remember cos a cos b formula? What's the cos a cos b? Yeah. So what's the Fourier cosine transform of? So cosine transform, this becomes cos. So this becomes cos a cos b. What's the cos a cos b? 2 cos a cos b formula is equal to cos a plus b plus cos a minus b. Plus cos a minus b. Yeah. Understand? So a equal to sx, b equal to ax. So this becomes 1 by 2 cos of s plus a into x plus cos of s minus a into x. So the same concept only, but the output is completely different. You see, completely different. Cos cos. So this becomes fc of s, fc of s. So for the cosine transform of f of x to cos ax is 1 by 2 for the cosine transform of s plus a plus for the cosine transform of s minus 2. So this is the various types of modulation properties under the complex Fourier transform as well as the Fourier sine and cosine transform. So this is nothing but the product of f of x along with the trigonometric function under the sine transform, cosine transform. Understand? I hope everyone enjoyed and understand this properties, modulation properties under the Fourier transforms. Thank you so much for watching our YouTube channel. Kindly stay back, let us see, subscribe the channel so that you can get notification whenever I upload some interesting videos. Thank you so much. Take care, bye.